Hello, mathematicians. Welcome back to another lesson of math workshop, continuing with decimals. We're now getting into lesson 5. The teaching point today is mathematicians show equivalence of tenths and hundredths using area models and place value disks. So we have two goals for today. The first goal is we want to be able to show how tenths and hundredths are equal, and we want to use an area model and place value disk to show this equivalency. And in this video, we're going to learn more on how to make certain that we understand how to practice this skill and get really strong at making these comparisons.
All right, this is fourth grade, module 6, lesson 5. And in this lesson, we're going to continue modeling tenths and hundredths, but this time we're going to be modeling it with the idea towards helping students understand the equivalence, that 4 tenths is equal to 40 hundredths. And we're going to be doing it mathematically, using this equivalence of fractions idea. And we're going to be using place value disks as well. So let's get started. So I'm going to start by zooming in. Let's take a look at just one square. And we're going to call that square one whole unit. All right, so that's one whole unit. And suppose we wanted to model 0. Let's do 0.2. Okay, so 0.2. Now we know that 0.2 is 2 tenths. So the first thing we want to do is let's model 2 tenths. So the idea is we need to cut this into 10 strips. So I'm going to do the best I can, and I'm going to cut this into 10 strips. 1, 2, 3, 4, 5. Holy moly, those don't look equal at all. But that's okay. We're estimating here. 1, 2, 3, 4, 5. So there's my 10 strips. And when we want to model 2 tenths, well, that's easy. We're just going to take our coloring pen and we are going to shade in 2 of those strips. So there we go, 1 strip, and here's our second strip. And so I've just modeled 2 tenths. Now, the idea is, but what if I went the other direction and I cut each tenth into tenth? So I'm going to cut it in half, and now I'm going to cut 1, 2, 3, 4, 5, and once again, these are just not equal at all. Man, I was trying my best. 1, 2, 3, 4, 5. There we go. So now I haven't added any red, but instead of seeing 2 tenths, we now see 20 hundredths. So what does that say? Well, that says 2 tenths is equal to 20 hundredths, because the same amount of red shading existed in both cases. All I did was just cut them into smaller pieces. So now 2 tenths is 2 big strips, while 20 hundredths is 20 little squares. All right. Now, what we want our students to recognize is, hey, wait a second, I see a pattern. 10 times 10 is 100. 2 times 10 is 20. And the idea is we want students to start to recognize this formal mathematical equivalence, that 2 tenths, when you multiply both the numerator and the denominator by 10, you get 20 hundredths, and 2 tenths is equivalent to 20 hundredths. And we can reverse that procedure as well. So reversing the procedure, we could say, well, let's start, if we wanted to, we could just do this. Whoa, we can look at it. We don't even need that other square. We could say, well, we know that I started off with 2 tenths. I know at some point I ended up with 20 hundredths. And we already know that 20 hundredths is equal to 2 tenths. So can I find a relationship starting with the 20 hundredths and going to the 2 tenths? And the idea is, yeah, we can divide both by 10. and we end up with 2/10. So 20 hundredths, when you divide the 20 by 10 and the 100 by 10, the numerator and the denominator are each being divided by 10, you get 2/10. So we can find equivalence by multiplying both the numerator and the denominator by 10, or we can find a relationship, an equivalence, by dividing both the numerator and the denominator by 10. And that's a really powerful technique, this multiplying and dividing idea. So here we're going to put it in practice. It says find the equivalent fraction using multiplication or division. That's what I was just talking about. And shade the area models to show that we are correct. So we're going to zoom in a little bit here. And we're going to say, well, 4/10. Well, 4/10. If we multiply that 10 by 10, we get the 100 that they want. So 10 times 10 is 100. So that means 4 times 10 gives us 40. So we know that 4/10, and I'm going to write it down here, 4/10 is equal to 40 hundredths. And that's really what it said up here. But this 10 stuff kind of hides it a little bit. So I'm being more explicit down here. 4/10 is equal to 40 hundredths. How do we know? Well, we're going to shade that in. So first we're going to shade in 4/10, and 4/10 looks like this. 1, 2, 3, 4. There's our 4/10. And now we're going to shade in 40 hundredths. So what does 40 hundredths look like? Well, 40 hundredths looks like, oops, I want that. There we go. 40 hundredths looks like this. Well, that's 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths. So we can see that 4/10 is equivalent to 40 hundredths. Now we can show that same idea only in reverse using division as our tool for showing equivalence. First we can do 60 hundredths. So what does 60 hundredths look like? Well, there's 10 hundredths, 20, 30, 40, 50, 60. So there is 60 hundredths. And then we know that if you divide both the numerator and the denominator by 10, so 100 divided by 10 gives us the 10 that we're looking for. So 60 divided by 10 gives us the answer of 6. And so we're pretty much sure that 60 hundredths is equivalent to 6/10. So what we're saying is, here's 60 hundredths, and we think it should be equal or equivalent to 6/10. Let's make sure. So let's just grab another color, and let's do blue. And we got, well, there's 1/10, there's 2/10, there's 3/10, 4/10, 5/10, and finally 6/10. So there, and we can see, hey, this and this, they're exact same amount of shaded in stuff. I don't know if I'm allowed, am I able to? No, I can't. All right, so we can see that they are equivalent, and so there you go, that division, when you divide both the numerator and the denominator by 10, you get a new fraction, but it is equivalent to the original. So here we're going to complete the number sentences and then shade the equivalent amount on the area model here. And we are going to have to draw some horizontal lines in order to make our hundredths. And the idea is, well, 36 hundredths. We want students to recognize that that is 3/10 plus an extra 6 hundredths. So how are we going to shade that in to our model here? Well, first thing I got to do is I've got to shade in 3/10. Well, we know what 3/10 is going to look like. 3/10 is going to be 1/10, 2/10, and 3/10. So there is our 3/10. Now what is 6 hundredths going to look like? Well, 6 hundredths means I got to take this 10th right here. I'm going to zoom in a little bit further, and we've got to chop it into 10 pieces. So I'm going to cut it right in half, and then 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So I've just created hundredths. So this blue stuff right here so far is our 3/10. Now we need to put in 6/100ths, and I'm going to zoom back in a little bit, and I'm going to color code it, and this time I'm going to do it in red just to differentiate. I don't need to, but I want to. So there's 4, 5, 6. So if we want to see what 36/100ths looks like, it's going to be 3 strips plus 6 little hundredths. So 3/10 plus 6 little hundredths. And so that whole thing right here, this whole piece right here represents 36/100ths. So what's a decimal notation form? It's going to be 0.36. What's the fraction form? It's going to be 36/100ths. And there you go. So here we've got a variety of different representations. We've got place value discs, we've got a number bond, we've got some decimals, we've got some fractions, plus we have it in unit form. So this is really giving students an opportunity to just compare a whole ton of stuff going on here. So let's just take a look at problem B, and we're going to count, and we see that they've conveniently put them in 10 frame form, in groups of 10. So we've got 10, 20, plus 4, so that's 24/100ths. So we're going to start with 24/100ths, and so as a number, as a decimal, that's going to be 0.24. And then what we want students to see is that these 10/100ths equals 1/10, and these 10/100ths equals 1/10. And if we wanted to write that out, 10/100ths, we want students to understand right off the bat that that's equal to 1/10. So if we have 10/100ths and another 10/100ths, that's 2/10, because these 10/100ths equals 1/10, these 10/100ths equals 1/10. So we now have 2/10, plus what do we have left over? We have 4/100ths left over. So we want to have students connecting the decimal form with its fractions in expanded notation. So that 2 represents 2/10, and this 4 represents 4/100ths. And now I can go back down here and I can fill that in. Hey, that's 2/10 plus 4/100ths. Now, parents and teachers, let your students bounce around in terms of how they fill this in. There is no magic order in terms of how they fill it in. In fact, that's the whole point, is to allow students to choose whatever access point they want to use in order to develop their understanding of the other representation.
All right. So what I'd like for you to do is I want you to get some practice with this. The first thing I want you to do is I want you to make certain that you are completing the lessons that your teacher has assigned to you on iReady. That's super important that you're completing those tasks. Additionally, what I would like for you to do is I want you to then go on to Zern, and I want you to complete lesson number 5 on Zern. If you're feeling that you want a little bit more guidance, don't hesitate to do the guided practice component and then go into independent practice. Set your timer. Don't stay on too long to the point where you're feeling frustration. I want you to take your time and pace yourself. So give yourself about 30 to 35 minutes. If you feel like you need to take a break, feel free to take a break so your brain is not exploding with decimals. If you feel like you need any additional support, you're welcome to call a teacher or reach out to a teacher or even a peer to further discuss. When you're checking your work, I want you to take your time, really think about what strategies you're using, make certain that you are using mathematical language to really challenge yourself through your thinking. If you have any questions, please do not hesitate to reach out. Once you're done with that, I want you to make certain that you're completing the exit ticket number 5 for today.